Alrighty, so we have a do now. The figure above shows the graph of the figure above. Okay, there's no figure above. Okay, this one, I can pretty much tell that this is probably the figure they're talking about, given that this has a negative x squared. So that means a parabola that's pointing downwards. Anyways, and the graph of the line y equals 2x, and that's a line. What is the area of the shaded region? So what's the area of the shaded region? So give that a try, and then I'll talk about it. So the way to do this problem, we're gonna do two integrals, one of the parabola and then one of the line, and we're gonna subtract the two. And here's why we're gonna do it. The parabola from 0 to 3 will be the area underneath the curve, right here. And then the line will be the area underneath the line, the integral, right here. So what's going to happen essentially is if I do both areas and I subtract the two, I'm taking away the blue from the green, and I'm going to be left with only this stuff, which is essentially what I want. So let's do this problem. So I did both integrals. So when I did the integral of this one, I ended up getting this. And when I did the integral of this one, I ended up getting that. So please verify that you did get the same thing as well. And then I just started plugging stuff in. So I plug in a 3 into my x's, which is why I got the x squared became a 9, the x cubed became a 27. So I have 5 over 2 times 9 minus 1/3 times 27, which will become 9. And then minus whatever this is going to be. The 0, I didn't really bother plugging in zeros because that becomes 0 anyways. But 3 squared is 9, so minus 9. So everything that's red underlined is what I got from right here. Everything that's blue underlined is what I got right here. Alright, so let's go ahead and finish that bad boy up. Alrighty, so I end up simplifying it a little bit, and then trying to get the common denominator. This becomes negative 18. Negative 18 is the same thing as negative 36 over 2 to get the common denominator. And now I get 9 over 2, which is the option that was highlighted before. Alrighty, so that's how I do this problem. Let's move on. So in this chapter, we're going to be talking about differential equations. Differential equations is pretty much a pretty fun chapter in calculus. The way it's going to work is you're going to get some kind of differential equation, which has pretty much dy dx equals y something, and then x something. And essentially what you're going to be doing is you're trying to get an integration of y on one side and integration of x on the other side. And then with some kind of initial condition, you're going to be finding out what c is. And then you're going to plug that back in. So let's do some examples. So let's do this. Differential equations, dy dx equals g times f of y. So g of x times f of y. Solve the differential equations dy dx equaling this. Find the solution of this equation that satisfies the initial condition y of 0 equaling 2. Alright, let's do this. First thing we probably want to do is get the y's and x's on the same side. So we're going to multiply by y squared on both sides to get y squared over here, and then we're going to multiply x dx on both sides to get dx over there. So that way we're going to have x squared to dx and then y squared to dy, so we can do an integration on both sides. Alrighty, so we're going to end up with something like this. So we're going to have the integration of y squared dy, integration of x squared dx. When you do that, you're going to be able to do this. And now we don't know if the constants are the same, but what we can at least do is merge the constants. So subtract c1 on both sides. So c2 minus c1 is some constant c3, or just call it c. And then we can pretty much solve for, because our initial goal was to solve for yeah, let's solve for y. So we're going to end up with y cubed equals all of this. Take the cube root on both sides, and we have our y equaling the square cube root of x cubed plus k. Now the good thing is we were given some initial condition. The initial condition was when you plug in 0, your y equals 2. So let's do that. So plug in 0 into x, you're going to get 2 equaling the cube root of k. So let's do that. So 2 equals the cube root of k. Cube both sides to get rid of that, and k will equal 8, giving us y equaling all of this good stuff. Alrighty, so let's see. Oh, that's it. Yeah, we finished. So that will be your equation. Alrighty. That is it. Let's do the AP question. Consider the differential equations dy dx equaling something with a y times something x. Let y equal f of x be the particular solution to a differential equations with initial conditions. When you plug in 0, you get 1. The function f is defined for all real numbers. And then, I guess part C of it, find y equals f of x, the particular solution to differential equations with initial condition. When you plug in 0, you get 1. Alrighty, so first thing we need to do is get the y's and x's together. So let's do that real quick. So it seems the best way to do this is to divide both sides by 3 minus y, and then multiply both sides by dx. That's the most convenient way, mainly because multiplying by dx brings dx right next to the cosine. So when we do this, we end up with this right here. So now we have dy over 3 minus y. We also have cosine of x times dx. So when you do the left side, that's going to be a natural log, but you have to account for the fact that you have a negative y right there. So attach a negative here in order to make sure that if you were to take the derivative, that negative cancels out. Just double check, like if you took the derivative of negative natural log of 3 minus y, would you end up with 1 over 3 minus y? And yes, you would, because this negative will cancel out the negative you would get from here due to chain rule. The right side is a lot easier, cosine to sine, which is awesome. For this example, I kind of didn't bother writing a c here and a c there and then subtracting them. I just wrote a single c, which again, it's got to go through some kind of transformation because I'm going to, by getting the y by itself, I'm going to divide by a negative 1. So we're going to get a c divided by negative 1, which is rewritten as c because we don't really care. Alright, so now we have our equation. We have the natural log of the 3 minus y minus sine of x plus c. And we're going to plug in our initial condition. There's no benefit in actually getting c by itself, given that it gives us this right here. When you plug in the function 0, your y should equal 1. So let's plug in this stuff. So I rewrote the condition right there. So where we see an x, we're gonna plug in 0. So we're gonna plug in 0 right here, and wherever we see a y, we plug in 1. So that's what we got. 3 minus 1 is 2. Natural log of 2 equals sine of 0 is 0. So c becomes natural log of 2. Plug that bad boy back in here. Now you got this. Now it's kind of worth it to get y by itself. So e to the power on both sides will get rid of this natural log, because now on the left side we're going to be left with 3 minus y. On the right side, so now let's look what happens here. You can separate it, because this is the same thing as saying e to the negative sine of x times e to the natural log of 2, which e to the natural log of 2 is easy to simplify, becomes a 2. So now we are right here. 3 minus y equals e to the negative sine of x times 2. We're trying to get y by itself, so subtract 3 on both sides, and then multiply by negative 1, and that should give you your final y. There we go. This is an AP question, so it's going to be subject to AP scoring. So go ahead and take a look at that, on how they would have scored it. Score it yourself. See what, where you might have lost some points, where you might have succeeded. See you guys tomorrow.